6.1 example 2 says, find the volume of the solid formed by revolving the region bounded by the graphs of f of x equals 2 minus x squared and g of x equals 1, rotated about y equals 1. Okay, I've drawn this picture so we can visualize what's happening. The region bounded is bounded by this graph right here, f of x, 2 minus x squared. And g of x equals 1. So this horizontal line right here is our g of x. And we're rotating it about y equals 1. This horizontal line is going to be our axis of rotation. The way that I figured out these endpoints is by setting them equal to each other. Where does 2 minus x squared equal 1? So if you weren't given these two endpoints, you figure it out by setting f of x equal to g of x. So that would be x squared equals 1. So x would equal plus or minus 1. So that's how I figured out these points right here. That's where they intersect. All right, so that would be our A and our B once we find our integral. Now we need to figure out what our radius is going to be. My axis is right here, horizontal. My radius of my shape, so this is the shape right here, and I'm rotating it on this line. So the radius has to be this value right here. But the radius isn't so simple this time. R of x isn't just the height at f of x, because that would be this whole shape right here. We have to take r of x and subtract g of x. We have to take f of x and subtract g of x in order to get this r of x. We have to subtract out this height right here in order to just have the height that's in between them. So r of x, in this case, is going to be f of x minus g of x. It's got to be this minus this in order to get the height that's in between them. So your r of x is going to be 2 minus x squared minus 1. So that'll be negative x squared minus 1 is going to be your r of x. Plus 1, sorry. So your r of x will be negative x squared plus 1. I'm going to rewrite that as 1 minus x squared just to look nicer. All right, we have our r of x, and we have our axis of rotation, and we have our a and our b, so let's find our volume now. Volume equals pi integral from a to b, negative 1 to 1. R squared, 1 minus x squared, squared, and it's a horizontal axis, so dx. So then I will, before I take the integral, I will square this, so I'll have 1 minus 2x squared plus x to the 4th dx. And then you just take the integral like normal, pi times x minus 2/3 x cubed plus x to the 5th over 5 from negative 1 to 1. And then you'll plug in 1. So pi times 1 minus 2/3 plus 1/5, that's plugging in our 1, minus, plug in negative 1, negative 1. This right here will be negative 1, so plus 2/3. And then right here it'll also be a negative 1, so minus 1/5. So we'll have 1 plus 1, negative 2/3 minus 2/3, and 1/5 plus 1/5. So we'll have 2 minus 4/3 plus 2/5. And then we could get a common denominator, 15. So pi times 30 over 15 minus 20 over 15 plus 6 over 15. So 30 minus 20 is 10, plus 6 is 16. So you should get 16 pi over 15. And that is your volume if you take this shape right here and rotate it on this axis, y equals 1. That is the volume of the shape that you will get.